Again, this is a very foundational concept for rational functions, which is what the new unit is.
I hear that P asymptote.
Right, so most rational functions have asymptotes. Not all of them do, but most of them do. We'll talk about later which ones don't. But for the most part, they have asymptotes. So the real question is, what is an asymptote? And how can we write them down as far as kind of like an equation goes? All right, so here's the first example of what asymptotes look like. They're normally drawn with dotted lines. And they're dotted because they're not actually part of the graph, okay? The real part of the graph right here, of course, is this solid black line right here. This is a rational function. These dotted lines are asymptotes. Now, can somebody maybe guess why they're there? So basically, they're there to show that the actual graph kind of forms around that line, right? It's shaped by this imaginary line. Okay? I will go ahead and tell you there's a common misconception that a graph cannot cross through an asymptote. That's 99% true. Sometimes it actually does cross. The key to an asymptote is that it helps form the shape of the graph. Yes, it still is an asymptote. So the definition we want to focus on is it's an imaginary line that helps form the shape of a graph. The curve will usually not touch an asymptote, but it is possible. Like I said, maybe 1% of the time. I don't know if I have an example on this particular lesson. Yes, I do actually. I do have an example where it actually touches. As you guys are copying, I will talk about the three types of asymptotes. It's either going to be vertical, which goes up and down, like this one. It's going to be horizontal. What's the third option, do you think? Not vertical. Diagonal, yeah. Actually, there are more than three types. There's also what's called oblique asymptotes, which means the asymptote itself is curved. We won't really look into those too much. It's a curvy asymptote. Huh? Oblique, yeah. But here we go. So example 1 says identify the asymptotes in the following graph, so we'll have to look at it in a second. And we're going to see the horizontal, the vertical, and if it has any slants. So the thing about an asymptote is it actually has an equation itself. We'll start by looking at the horizontal asymptote. Okay? Does anybody know the equation for that? Y equals 0. Right. Because the y value, the f of x value, is always equal to 0. Remember, a horizontal line has y equals for an equation. So we're going to fill that in and put y equals 0. How about the vertical asymptote? Okay, so that is correct. A vertical has an x equal for an equation. In this case, it's on 0. It could be over here, right? It could be x equals 4 or x equals negative 5, doesn't matter. And then for this one, it doesn't have any slant, but we will do one in a second that has a slant asymptote. So this one has none. No slant asymptote. Any questions on that first example? Pretty simple. Let's do another example. We're going to find the horizontal, vertical, and slant. Now, of course, we're just looking at graphs today. You can do this if you're given the equation, which is much more involved. Today, we're just looking at the graphs. So, first example, we will go ahead and look at the horizontal asymptotes. What do you think the answer is going to be there? There is none, right? No horizontal. There is a vertical, yes. No horizontal, okay? What is the vertical? X equals negative 0.5, that number right there, okay? Slant, this is kind of a flashback to Algebra 1. You need two things for an equation of a line. The y-intercept and the slope. Okay? Let's start with the y-intercept for this one. Can everybody see it's negative 0.25? Okay, so here on the side somewhere, I'm going to write b equals negative 0.25. We'll use that in a second to figure out the equation. And then what is the slope? Well, you can start at any point, right? And then go up and over. Let's start at this point and then go up and over. We're going up 0.25 and over 0.5. So that means the slope 0.25 over 0.5. Now what does that simplify to? 0.25 over 0.5. 1/2, yes. It's a quarter over 50 cents, right? There's 2 quarters and 50 cents, so the slope is 1/2. Now the final piece of the puzzle, what's the equation for a line? Well, no, not like in general. Yes, that's both of you are right, but I just wanted to write out the general formula.
I remember that. That's all I remember.
Y equals mx plus b, which means in this case, y equals negative 0.25 x plus, and guys, listen up for a second. Oh, you're right. I'm sorry. I messed up. Thank you for correcting me. Okay, so it's y equals 1/2 x minus 0.25. And again, what are we finding? This is the equation for the slant asymptote. Okay, so the slant asymptote has this equation. It's just a line that forms the graph. It's not the equation for the actual graph. It's the equation for this dotted line that forms the shape of the graph. This graph curves around that line. And that's what we found, the equation for that. Imaginary line. Again, an asymptote is an imaginary line. This is an equation for a dotted imaginary line. That's correct.
I hate math so much. I don't know.
Shh. Next example. So here we have an asymptote, and it's an asymptote because it forms the shape of this graph, and it just so happens that the graph does actually cross through it. Now what makes it an asymptote is that it forms the shape of the graph. In other words, the graph kind of is shaped around it. So I wanted you to see that, yes, it is possible. Now we're going to fill this one in real easily, right? There is no vertical, there is no slant, there's only a horizontal for y equals 0. Now I don't want you to blur anything out. I'll let you think about this as we finish the lesson up. Again, don't say anything. I want you guys to try to think of an example of a rational function that has no asymptotes. So you actually have to come up with an equation. If you can't come up with it, it's fine. If you can, I'll give you extra credit. Again, don't blur anything out. Like I said, just think about it. Okay, so you don't have to write this down, but basically what this is saying is an asymptote, a graph can cross through an asymptote. Okay?
So it can only cross through a horizontal asymptote?
Actually, that's a good point. Yes, if you really want to know, it will never cross through a vertical. As far as slant goes, I don't know about that. As far as I know, it won't cross through a slant. But it cannot cross through a vertical asymptote. So guys, what I want you to think about is an asymptote is not necessarily a brick wall. It just helps form the shape of the graph, just like we have here. I wanted to show you an example of an oblique asymptote. We're not going to really study these too much in this class, but an oblique asymptote does occur. It's a curved asymptote, and you guys can see that this graph does actually form around that curved line. Again, in this class, we probably won't be finding oblique asymptotes. They do have equations. This looks like a quadratic asymptote. I just want you to know they exist. And I do want to mention one more thing about what you're talking about, rational functions. For it to be a rational function, it has to have a fraction, and the variable has to be, there has to be a variable in the denominator, okay? So, again, my question to you is, can you find a rational function that doesn't have any asymptotes? And I'll leave you with that one, and if you figure it out, I'll give you a